So it must have some other oxidation number. Why can't it have 0 as an oxidation number on the other side as well? Because then it wouldn't have changed, huh? You'd have O2 on the left and O2 on the right. Why was it in the equation if it didn't undergo a change, right? So if you see something in its elemental form, it must be an oxidation reduction reaction. That takes care of the first three, doesn't it? Now, what about the fourth one, D? You know, how do we know it's an oxidation reduction reaction? Not because there's nothing in its elemental form. What we would do to make sure that that last equation was not an oxidation reduction reaction is we would figure out what the oxidation number is for everything. And see if anything changes. Barium, got a rule? It's probably good for you to have a periodic table out. Why don't you take the periodic table out?
Is that good?
Barium is a group 2 metal. Do we have a rule for group 2 metals? Yeah, we do. They're always +2 if they're not in their elemental form, right? Everything in its elemental form, it has 0 as an oxidation number, right? But if a group 2 metal is not in its elemental form, then it's going to be +2, right? +2. Oxygen, got a rule? -2. Hydrogen, got a rule? +1. Hydrogen, +1. Sulfur, got a rule? The answer is no, we don't have a rule. If sulfur gets to have its way, and when would it have its way? Who's next?
Brian.
I am.
Yeah.
What is this? Wait, Riley, what line?
Amanda's not here.
Why doesn't he have to be private stuff?
Okay, ready? Come back. If sulfur gets to have its way, when would sulfur have its way? Like this. Right? If sulfur were reacting with a metal, it would get to have its way. It would be able to take electrons. If it was with hydrogen, 2 nonmetals, but who has the higher electronegativity? Sulfur does. It gets to have its way. Sulfur here is bonded to oxygen. Does it get to have its way? Who gets to have their way? Oxygen, which is -2. There's 4 of them, so each is a -2. That's -8. And a +2, the sulfur is +6. Now, when you're writing oxidation numbers, don't write the oxidation number of the oxygen as -8. Because you look over here and say, ooh, it's -2 there, it must have lost electrons. It didn't lose electrons, did it? Okay. All right. Barium got a rule? +2. Sulfur got a rule? No. Oxygen's -2, there's 4, that's -8. But the +2 means the sulfur is +6. Hydrogen +1, oxygen -2. Has anybody changed their oxidation numbers? No. This is not an oxidation reduction reaction. Okay? Riley, who are we recording for today?
Amanda.
Amanda. Hi, Amanda.
Let's all be resentful towards him.
Yeah.
In a nice way.
Yeah.
Amanda, I hope you're having fun.
Yeah. Amanda's off having fun, and we're stuck here in class.
Why are you helping?
Why am I helping her out? I don't know. I should make her pay me.
That's right. You should just.
You should.
You should just. Yeah. You should just turn the camera off. She doesn't. She's having too good a time.
Turned it off. Sound off like a little blank.
Ooh, you know, we could like for 10 minutes we could like film wrong things. I could just do everything wrong on the board. You know? Another question on the problem set.
See all this.
6.
Number 6. What's the oxidation number of manganese in lithium permanganate? LiMnP. Manganese, got a rule?
No.
No. Lithium, got a rule? +1. Oxygen? -2, and there's 4 of them, so that's -8 and +1, so this must be +7, because the oxidation numbers of the atoms in a group of atoms have to add up to the charge on the group of atoms. 0 if it's neutral, or whatever the charge is on the ion if it's a polyatomic ion, right? For instance, if I had said, what is the oxidation number for the permanganate ion? You'd have said -2 for oxygen times 4, that's -8. So in order for the oxidation numbers of manganese and oxygen to add up to -1, this would have to be +7, right? +7, -8 leaves a -1 for the charge. We are accounting for electrons. So far, everything we've done is review, isn't it? Right? Are we done with the first 10 on the problem set?
Are we doing any more labs this week?
I don't know, I'm gonna have to see next week. We might have enough time to do a lab on Wednesday.
What day are we gonna return to this? So I can
The day of
remember
the
to
final?
bring them.
Of course, you need your book right up to the final, huh? So when you come to take the final exam, you'll bring your books. Right, you bring your books with you, right?
Well, what are the answers to 3 and 4?
You'd expect scandium to lose electrons, it's the metal.
Yeah.
Take those back with you. She wasn't here. Here. Yeah.
Both of them?
Yeah. Thank you. I'm going to throw this away because this is why Sandra came to get Brian. So.
What were you there for?
All right. Where were we? Oh, number 3, it would be the scandium that would lose electrons and be oxidized. Number 4, in a reaction between nitrogen and sodium metal, which element would act as the oxidizing agent? Well, who's getting oxidized? The sodium would be losing electrons. That's what we expect elemental metals to do. So, who would be taking those electrons away? That would be the oxidizing agent. The nitrogen would act as the oxidizing agent.
Should we take a break?
No. Well, why don't we take a break once we've finished?
Yeah, not yet.
That was a terrible.
What was the answer to number 10?
Number 10, it's the bromine that loses electrons. It goes from -1 on the left to 0 on the right. And as a little extra practice, who's taking the electrons away from bromine? Manganese goes from +4 on the left to +2 on the right. So it's gaining electrons, isn't it? And let's take 5.